Okay, so day 4, dividing, and let's start with the easier method, I think. Well, I'll say easier, but if the problem is just a division problem, okay, it's not asking you to model, okay, not asking you to explain anything, and you just want the answer to division problem, you're probably better off using this method. Let's take a problem, 3/4, and it says divide that by, I don't know, let's pick 5/6. Okay, the one way you did it is by changing this problem into a multiplication problem. Okay, so 3/4, the first fraction, stays as it is. You're going to change the division to multiplication, and you're going to flip this upside down. So the 5 goes to the denominator, and the 6 goes on top. So you flip it around, that's the reciprocal, and you get that. Then you multiply numerator times numerator, which is 18, 4 times 5, which is 20, and you get 18 over 20, which simplifies to 9 over 10. Okay, so this is one way of dividing. Let's go back, I should take a step back and talk about reciprocal. What's the reciprocal of a number? Well, let's take the number 2/3. What can I multiply this to get an answer of 1? Well, I multiply 2/3 by its reciprocal, and the reciprocal was going to be 3/2. How does that equal to 1? Well, because 2 times 3 on the top is 6, and 3 times 2 on the bottom is 6. And 6 over 1, 6 over 6, is the same thing as 1. Okay, let me try another one. 5. 5 times what will give me 1? So there's a reciprocal 5, and if you got 5, you can put it as a fraction, first of all, by putting it over 1. And now you can find the reciprocal by flipping this. It becomes 1 over 5. And if you multiply it, you get 5 times 1 on top, which is 5. And 1 times 5 on the bottom, which is 5. And 5 over 5, again, is 1. Okay, so that's the reciprocal. Reciprocal of a number is a number that, when multiplied by the original number, it gives you 1. Okay, we'll do one more. I don't know, 7 over 9. I'll find the reciprocal so that when I multiply it by 7 over 9, it gives me 1. And again, 7 over 9, you flip around, comes 9 over 7. 7 times 9 on top is 63. And at the bottom, 9 times 7 is 63. And 63 over 63 is just 1. Okay, that's reciprocal. Let's do a couple more here. Okay, and my super fast computer. Let's do again, if the test or the question is just a simple division problem without any explanation, and you just got to show the result, this is the method I would choose. 2 1/3 divided by 4/5. Okay, again, in this case, remember, if it's a mixed number, whether you're multiplying or division, just in division multiplication, you want to change it to an improper. This becomes 3 times 2 is 6 plus 1, 7 over 3. Okay, and then division becomes a multiplication, and you're going to flip this around. The reciprocal of 4 5 is 5 over 4. And now you're ready to multiply. 7 times 5 is 35. 3 times 4 is 12, which you can change to a mixed number. 12 goes into 35 2 times. 9 left over. Ooh, not 9. 24, 11 left over, I'm sorry. Over 12. Okay, so that's multiplying with the reciprocal. The only thing you had to change it was the mixed number into a improper. Okay, pretty simple. Okay, so that's dividing by changing to a multiplication problem. Okay, the first fraction stays the same. Change the operation from division to multiplication, and you change the last fraction to its reciprocal. Okay, simple enough. Now, when my computer stops moving around, we'll go to the next page. Dividing and LCM method. I don't know, there's no name for this, so this is what I mean. Let's take 4 over 9 and divide it by 1 over 9. Okay. Now, when the denominators are the same, obviously you don't have to find the LCM. Okay, so you're good here because the denominators are the same, so there's no need to. But the one thing that you can do is cross these two guys out when they are the same. And 4 over 9 divided by 1 over 9 becomes just simply 4 divided by 1. And what's 4 divided by 1? It's 4. Why does this work? Because you're dividing things that are of the same unit. Okay, so let me see if I can draw this out. So, oops, not there. Let's figure out what 4 over 9 looks like. 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's draw what 1 over 9 is. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4 over 9 would be 4 of these. 1, 2, 3, 4. And 1 over 9 would be these. Notice that each slice here is the same, so it's since they are the same, this guy fits inside this box nicely because they're the same size. This guy fits inside that box nicely. This guy fits inside this other box, and finally this guy fits inside that box. All these boxes are the same size. Okay, and as you can tell, that's no different than, say, what's 4 divided by 1, which is also 4. So you can say it as 1 over 9. How many times does this 1/9 fit into 4/9, right? Be 4 times, or what is 4 divided by 1? Now, here's where the LCM method comes. So now, if you had 2/3 divided by, I don't know, 1/4, then in this case, you will need to find the LCM, which in this case is 12. Okay, so this is be 3 times 4. Top one would be 2 times 4, which is 8. 4 would be 4 times 3, and the top one would be 1 times 3, which is 3. And there we go. Our denominators are the same. So you can cross them out if you like, because the units are the same. And you end up having 8 divided by 3, and 8 divided by 3 is 8 over 3. Or, as a mixed number, is 2 and 2/3. I'm going to use models to prove that to you. So you have 8. Let's do sticks. 1, 2, 3, 4, 5, 6, 7, 8. And you want to make groups of 3. Here's one group of 3. Here's another group of 3, that's how I got my 2. And I'm trying to make another group of 3. Can I? No, but I can make 2 out of the 3 that I wanted. And that's how I got 2/3. I can make one full group of 3, another full group of 3, and this one I can't exactly make a full group of 3, but out of the 3 that I want to make, I can make 2 out of the 3, and that's what my answer says. Okay, let's do quite a few of these again. Okay, get used to it. Let's see. 5, 6 divided by half. Okay, now LCM is 12, so let's change our fraction so it become 12. 6 was 6 times 2, and this 5 would be 5 times 2, which is 10. Here would be times 6, and the top would be times 6. So you get 10 over 12 divided by 6 over 12. Again, because the denominator is the same, you're allowed to cross these out. You end up getting 10 divided by 6, which is 10 over 6. And you can say that that equals 6 goes into tens one time, 4 left over 6. Let's not simplify yet because I want to show you using a picture. So what's 10 divided by 6 look like? Well, 10 divided by 6 looks like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you're trying to make groups of 6. So let's make a group of 6. 1, 2, 3, 4, 5, 6. Here. I can make one group of 6 right here. That's where my 1 came from. And then I'm going to try and make another group of 6, but you notice that I don't have enough. So out of the 6, how many can I put together? I can put 4 together out of the 6. Okay? I didn't simplify because if we simplify, the picture doesn't come out the same. But that's how I got the number. Okay, which is exactly the same if you were to leave it use fractions. Let's see if I can do the same thing. 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'll do the same exact, well, not the same exact, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and on the top one I have 10 out of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At the bottom I have 6. 1, 2, 3, 4, 5, 6. So, how many times does this guy right here, these 6, can fit in this group on top? So, again, I want to make groups of 6s, right? So I can make 1, 2, 3, 4, 5, 6. Up to here will be one group. And then I'll make another group of 6, but as you can tell, I can't because I only have 4, so I can make 4 out of 6. So one full group of 6 and 4 out of 6. Exactly the same thing. Okay? Just a little more. 2 1/3 divided by, I don't know, 2/5. Okay, so the first thing you want to do is change this guy here to improper. 6 1/7 over 3 divided by 2/5. Okay, I changed the mixed to an improper. Now I want to make sure that they have the same LCM. Okay, so it's times 5, it's 35 on top. And at the bottom is times 3, which is 6. My units are the same, so I can cross 15 out. And this becomes a problem, 35 divided by 6. Okay, so let's write it as a fraction. So it means that 6 can go into 35 5 times? No, yes, 5 times. Then 5 left over 6. Okay, I'm not going to draw 35 sticks right now. Okay. Let's do one where the second fraction is a little bigger. So 1/3 divided by 4/5. Now, I'm not going to be able to draw that. 1/3 divided by 3/4. There we go. Same thing. LCM is 12. Okay, times 3, so this is a 4, and that's what's 4 times 3 is 12, so therefore it's top times 3 to get 9. So how many times can 9 over 12 get into 4? Well, if you do it just the way we are doing right now, you cross out the bottoms because they're the same, your answer is 4/9. Why is your answer 4/9? Well, let's think. You have 4, right? 4, and you're trying to divide it by 9. You're trying to make groups of 9. Can I make a group of 9 here? No, I can't. But out of the 9 that I'm trying to put in a circle, I can put 4. And that's what that means. I can put 4 out of the 9 that I initially wanted to put. Okay. Let's try another one. 5, 6 divided by half. Okay, so the question is, LCM is necessary, which is 12, so 6 times 2, and on top is 10, and this is 2 times 6, which makes the top times 6. Okay, you can cross this out. Didn't I just do this problem? So 10 divided by 6 is 10 over 6. Are you asking yourself how many times can 6 go into 10? Or how many groups of 6 can you make with 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can make one group of 6 right here. And I have 4 left over out of 6. Pretty sure I did this problem. Okay, so I like this method because you can draw this out. Okay, so let me get to a problem here. Okay, I have 5/8 of a pizza pie, of a pie left. Okay, I want to divide it by 3/4. Okay, use a model. So 5/8 divided by 3/4. Yeah, you don't really want to do a model with these numbers. A, it's confusing. B, it's much easier if you find the LCM and draw a model then. So LCM is 8. One's already at 8. You don't have to change it. So this one's a 4. And it's times 2. So on top it's times 2. So you get 6. So you can cross these out. And the answer is 5 divided by 6, or 5 over 6. Now if they show you a model, okay, you can use this fraction, the one with the same LCM, same denominators, to show the model. The model would be, here's a model. Something that you have 5/8. 1, 2, 3, 4, 5, 6, 7, 8. And you want to show 5/8. 1, 2, 3, 4, 5. That's 5/8. Okay. And you want to show 6/8 now. 1, 2, 3, 4, 5, 6, 7, 8. And here's 6/8. 1, 2, 3, 4, 5, 6. How many times does 6/8 fit into here? Well, I have 6 pieces here, and I'm trying to fit into something that has 5 pieces. Obviously, I can't fit it all, but I can fit how many of the 6? Out of the 6, I can fit 5. I can fit 5 out of the 6, and that's why my answer is 5/6. Okay. Let's do one more. No idea what to do. I have 2 2/3. This is not right. Okay. I have 2 2/3 cups of sugar, of invisible sugar. Okay. Did I write 2? I want to see how many 1/4 cup of sugar I can have. That makes no sense. But you have 2 2/3 cups of sugar, and you want to break them down into 1/4 cup of sugar. So maybe you need it to make recipe. So recipe says you need 1/4 cup of sugar. So to make brownies, I guess. Okay, so a brownie recipe says you need 1/4 cup of sugar to make one brownie. Okay, so if I have 2 2/3 cups of sugar, how many brownies can I make? Well, it's a division problem. 2 2/3 divided by 1/4, and they also want to model. So pretend they also want you to model this. 2/8. So let's change this. 3 times 2 is 6. It's 8/3 divided by 1/4. Okay, and again, alright, so the LCM is 12 times 4, so this is 32, times 3 here would be 3. Okay, So the denominators are the same, so you can cross them out. So this would be what I'm doing here. I guess it would be the showing work. Okay, part of the problem. 32 divided by 2 is 32 over 3. And that would equal to 3 goes in 32 10 times, and 2 left over, 2 over 3. So how many brownies can I make? If each brownie requires 1/4 cup of sugar, I can make 10 and 2/3 of a brownie. 10 complete brownies and 2/3 of another one. By showing a picture, you would use this guy right here, okay, to draw. So what do we have here? We have 32 over 12. Oh my god. Alright, I'll draw it. So 32 over 12 will look like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I drew one more. So let's get rid of that last one. Okay. And what I can do is clone this 3 times. Clone. And clone that again. Or not. There we go. Clone. So, and we want to show 32. Okay, so this would be 12 plus another 12 is 24. Okay. And you got 25, 26, 27, 28, 29, 30, 31, 32. That would be 32 right there. Okay. You have 32 pieces that are 1/12 this. This is 1/12. That's 1/12, 1/12, 1/12. So you have 32 1/12 pieces. And you want to see how many times. I'll draw another 12 again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I want to see how many times these guys can go in there. So it would be 1, 2, 3. Alright, so you got groups of 3 here. So how many times this group of 3 can fit in the above? You can make it 1 right here, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can make 10 groups of 3, and I'm trying to make another one, but I can't make a full one, but I can make 2/3. There we go with pictures. Okay. I don't know if I should do another one. Okay, but that's that. Okay, so I'll stop here, and that's it. Oh, here is your word for day 4. Oops, let me cross that out. Okay. Your parents may actually know this. Yeah, some of you. There we go.